ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ನಾನು ಮಣಿಭೂಷಣ್ ಡಿಸೋಜ. ನಾವು ಲೈನೆಕ್ಸ್ ಎನ್ವೈರ್ಮೆಂಟ್ನ ಬಗ್ಗೆ ಕಲಿಯುತ್ತಿದ್ದೇವೆ. ಇಂದಿನ ಸೆಷನ್ 19 ಆಗಿರುತ್ತೆ. ಇಂದಿನ ಸೆಷನಲ್ಲಿ ನಾವು ಇನ್ಪುಟ್ ಔಟ್ಪುಟ್ ಸಬ್ಸಿಸ್ಟಮ್ನ ಬಗ್ಗೆ ಕಲಿಯಲಿದ್ದೇವೆ. ಇನ್ ಪರ್ಟಿಕ್ಯುಲರ್ we are going to look at the driver interfaces. The learning objective for today's class is to understand the input output subsystem and its usage. In order to appreciate the content of this particular section, you need to have the basic knowledge of the Unix architecture. Now let's look at what is input-output subsystem. Now we know that the kernel has to interact with the many different types of peripherals or the devices. Now, how does the kernel interact with the different varied varieties of the hardwares which are there in the system? The answer for this is the input-output subsystem. The input-output subsystem allows the process to communicate with the peripheral devices. These peripheral devices can be a disk, a tape drive, a terminal, or a printer, or even the network cards. The kernel modules that control the devices are known as drivers. So drivers are a special type of modules which help the kernel to control the various devices that are connected to the system. When we look at the driver and the different types of devices, there is a one-to-one correspondence between a device driver and the device type. What do I mean to say that is, suppose if you have a device called as a keyboard, then there will be a driver which is associated with that keyboard. That means your keyboard device driver and the keyboard, there is one-to-one correspondence. Similarly, if you have a hard disk, there will be a corresponding driver that is associated with it. So there is a one-to-one correspondence between the hard disk device driver and the hard disk itself. So if you have a device, any device for that matter, monitor, keyboard, mouse, or USB or anything, there will be a device driver and there will be a one-to-one correspondence between a device and its corresponding device drivers. So for a general consideration, now these device drivers may control more than one type of devices. So you may have the disks here, many different disks here. They may be all be controlled by one device driver. So we generally say that device driver type. So this is a block type. If you say it is a block type device, so generally the hard disk or this kind of devices are block devices. For all the block devices, there will be one driver. So a driver controls a type of devices. So what do I mean to say that? The block devices are used for controlling the devices such as the hard disk or the disk in that matter, but they may not be able to control a keyboard or a terminal, which are usually character devices. For these character devices, we may also have their own driver. So a device driver controls many physical devices of a given type. So for a given type, like a block device, you have a block device driver. For character devices, we have a character device driver. So there is a device driver that controls many types of or maybe one type of devices, many devices of one type. In other words, so a device driver controls many physical devices of a given type. Now, these devices are distinguished by the driver. Okay, so the driver knows which is which device, so which is which hard disk, which is which disk, which is which keyboard, and so on and so forth. So there is a way in which it distinguishes the different devices. Okay, now we know that in Unix file system, every device is represented in the form of a file, and it is generally accessed like a file. So whether it is a keyboard, whether it is a disk, whether it is a mouse, whether it is a terminal, everything is represented in the form of a file. And everything, if you want to interact with any of the devices, we are actually interacting with the file. Okay, these files are distinguished from the other regular file by the inode type. So in the inode, we have a type of the file. So let's look at the example. Now suppose if I go to my Unix system and I'm going to log into my Unix system, and in this Unix system, let me zoom in for you. So I'm at the root. If I use the ls, let me click here, and if I type ls, I'm going to get a particular directory called as dev. Now if I go into that dev, and if I ls, you will find many of them. So for example, you have a terminal, so you have the disk, and so on and so forth, and many devices. Let me go and let me say ls minus L to just get the long listing, and you will notice that whenever you find a device, if it's a character device, it will start with the C here. You can notice C for character device, and for block device, if I slightly go up, you may find some block devices. So you will notice that these are block devices. So this distinction is obtained because of the inode. So device special file has an inode, and it also occupies a place in the directory hierarchy. You notice that even though the STA may be a hard disk, or TTY may be a terminal, but in the hierarchy of the file system, you will notice that there is a file, there is a special file, and when you say it's a file, it's also associated with a inode. So you will find that it is like a file, like an ordinary file, even though it is a physical device, or even though it is a device, it is represented inside Unix as a file, and because it is a file, it will occupy a place in the directory, and it is associated with the inode. Okay. A device file is distinguished from the other files by the file type that is stored in the inode. I have already shown you that in order to distinguish between a device file and the other file, or a special type of file, and the regular file, the inode has a field called as a type of file, and in that type of file either B or C is written. For B for block devices, C for character devices. If the device has both the functionality, like it can work like a block device as well as it can work like a character devices, it is not represented by one single file, it is represented by two files. So one for the block and the other for the character. Now there are many situations wherein you may want to fine tune your system. So you know that when you buy a new vehicle, you will adjust its mirror, or you will adjust some settings so that it will fit to your need. Okay. So when you brought your mobile, you change this wallpaper and you also made some setting so that it is comfortable for you. So this is nothing but you are configuring, you are changing the settings. So system configuration is a procedure by which administrators specify the parameter that are installation dependent. So when you install a Unix system on your laptop, you may have to configure it. What is the meaning of saying configure it? Is you may have to change the parameters that are specific to the devices. So if you install it Linux or Unix system on a desktop machine, then you may have to fine tune some of the parameters so that it works fine with the hardware. So system configuration is a procedure by which the administrator can specify the parameter that are installation dependent. So these parameters specify the size of the tables, okay, such as we have process table, inode table, file table, and maybe the number of buffers that are allocated in the buffer full. These are all parameters that you can fine tune it. This is, I am talking in terms of the kernel. Definitely you can change its wallpaper and so on and so forth. You can do it. That's not that's also called as a configuration. But because we are talking about the architecture of the Unix, let's stick on to the system configuration in terms of the kernel. So we know that every process will occupy a process table, and there is an inode table. We can fine tune them depending upon our requirement. That is not Unix is not a rigid operating system that you can't make changes to it. You are free to make changes, and this procedure of making changes is called as system configuration. So whenever you make some changes to the parameters which are there, you can we call it as you are configuring the system. So how do I change the configuration? There are mainly three ways in which you can change the configuration. First one is whenever you get the source code, you know very well, even though when we use the Windows operating system, we don't bother about compiling it. But when we get the open source software in particular, sometime only the source code is given to us, and we need to compile it on our machine so that it fits onto our machine. Maybe they just give us the code and then we need to compile it. So this is a procedure generally being done, but as a student you may not do that thing. You may just get and set up file and double click on it and then say next, 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 and then everything gets installed. But that's not the case. When sometime you just get the source code and you need to do that thing. Okay. Suppose if you want to do the configuration during the compilation and linking, you can change the configuration and then build the kernel. That's one way. So that is when you get the source code and you want it to be compiled in such a way with all the parameters set on it, you can get it, change the parameter, compile it, and then run it. Or when the system is running, you can change the configuration. So there will be many configuration which are associated with the Unix file system, and you can always change it. Now suppose if you go here to your Unix system, let me go to the Unix system and let me double click on it because you are not familiar with the black and white world. So if you go into the file system, so you have many places wherein you can change the configuration. Now you notice here CONF. Oops, so I will just get it to the other side. Okay, let me zoom in because you may not be able to see here. What did I do is I went to a folder called as etc in my root. Here I have etc folder. I just open that etc folder and you will notice something called as CONF. Okay, these are configuration information. You can always change the configuration just for reference purpose. I'm going to open it. I'm not going to make any changes to it, but just to see what are the content. I will just open one of them. Again, I'm doing it in the colorful world so that you are familiar with it. Nowadays, you are not familiar with the black and white world. So that's why I'm not trying to open it in the console, that is a command prompt. So you notice there are like how to control the source and so on and so forth. You notice some information is there, so you can change the parameter here. If I open something else, okay, maybe where is some good one. I'm not getting something good that you will see. Okay, I think. Okay, I will open one of them. Login. Not getting any good one. Okay, something. Okay, I'll just open one of them, and you will notice it is not, and that's why I didn't want it to open something which is which doesn't have anything. So you will find bad that nothing is there in that. So if something really has, okay, where is when I really want to open something, I'm not getting something really interesting one, but you really get it. I'm going to just open one of them. So just if something is there, just see enough something is there, and you notice that you have some parameter. Ext is feature is general, block size is this one, inode size is this one, inode ratio is this one, and this is when you make a the file system. So you, when you create a file system, what must be the default value of the block size, what must be the default value of the inode, what must be the ratio, and so on and so forth. And these are some of the information configuration which is there. You can, if you want, you can fine tune them. So this is what is called as configuring the system. So you can always configure the system. Let me come back to my presentation. So one is when you compile it, you can do it. Other one is when the system is running, you can change the configuration. There is one other type which is called as self-identifying devices. Now what these devices are generally doing is like your USB. When you insert a pen drive, the actually pen drive is a device, so every device is associated with the device driver. And how do you configure it? So when you insert a pen drive automatically gets identified. So these are called as self-identifying devices. The kernel automatically recognizes those devices and installs the appropriate drivers. So sometime definitely when you install a new pen drive into your Windows system for the first time, at least you might have seen installing driver, and then it says your device is ready. So that means it is trying to install a driver that is able to communicate with that particular device. Okay. Now when we look at the interaction between the kernel and the driver, there are two interfaces that comes into picture. One is the interface that the kernel has with the driver, and the other one is the interface that the driver has with the device. So kernel interacts with the driver, driver has one more interface with to the devices. So you can imagine that this is your kernel. So you have your kernel, just a raw picture. This is your kernel, and in middle you have your driver. So you have your driver, and this driver interacts with the devices. So there are two interfaces. One is the interface between the kernel and the driver, and there is one more interface between the driver and the actual physical devices. So let's look at the first interface, kernel to driver interface. So for a block devices or for a character devices, there is a special type of table called as block device switch table and a character device switch table. So these help the kernel to interact with them. So whenever a kernel wants to read or write or do anything on with the devices, it checks for the device in the two tables. If it's a block device, it's going to search in the block device switch table. If it's a character device, it's going to search in the character device switch table. Okay. Depending upon the type of devices, these device types has an entry in that table that the kernel can use to interact with the system. Okay, so it gets the particular device and then makes the system call to interact with them. So for example, if it's a character device, we know that we have the open, close, and so on and so forth. We have seen many system calls, and these system calls, depending upon the type of devices, whether it is a character or whether it is a block, they are going to call the appropriate device, and this driver in turn, so there is a interface between this driver and the kernel module, and this is true even for the block devices. You have the interface, and the driver in turn will interact with the appropriate devices. Okay. So let's look at the other type of interface, that is hardware to driver interface. So here, because the kernel has to interact with the appropriate hardware, so all the things that register or any parameter are specific to the device. So it's interface towards the device. So hardware to driver interface, it consists of a machine dependent control register or input output instruction that help the driver to manipulate the devices or to listen to the interrupt. So whenever a device interrupts, like when you say, whenever you press a key on your keyboard, the keyboard is going to generate an interrupt. So whenever you move a mouse, the mouse is going to generate a interrupt. Okay, this is called as a device interrupt. When such a device interrupt occurs, the system identifies the interrupt device and calls the appropriate the interrupt handler. So suppose if you press a key on the keyboard, the device generates the interrupt. Now this interrupt is handled by the driver, and it will call an appropriate interrupt handler to handle the particular type of interrupt that has occurred on the system. Thank you for your interest. We will meet again in the next class. Thank you.